So hello and welcome friends to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So in our previous session we have seen a online platform called as virtual labs, which has been developed by institutes like IITs and NITs. So this platform offers the simulation of different experiments from different engineering subjects like dynamics of machinery, or let's say strength of materials from mechanical side. So you can find labs from different branches, from like electronics engineering, computer engineering, then biotechnology, mechanical, civil. So this platform offers a huge variety of labs with simple animations and simulations, so you can learn lot of things from this online platform. So without wasting time, let's check out what this platform is. So just type virtual labs and you could see the virtual labs are here. So just click on that and you will direct it to the home page. So this is the home page, and you could see it is an initiative of Ministry of Education under the National Mission on Education through ICT. So this is great mission, and we can see what is the main objective of this thing is to provide the remote access to simulation based labs in various disciplines of science and engineering, so that you can learn by sitting in your homes, right? So you don't have to go in at some place, you don't require any physical instruments, right? And if you could see the participating in institutes, so these are all like IITs and NITs and these institutes. And if you could see the areas, they have got all the areas start from electronics, mechanical, electrical, biotechnology, civil, physics, chemicals. All these fields have been included, and these institutes have put a lot of efforts to make these labs, and this is a completely free platform, right? So you don't have to pay anything, and you are getting a lot of knowledge by a single click. You just have to follow the procedures and you will get a lot of knowledge. So today we will see some of the labs, let's say from mechanical engineering. So for that purpose you have to go to the mechanical engineering. So just click on the mechanical engineering and you will go to the mechanical engineering. So these are the labs which are offered under mechanical engineering subject, and you could see the labs ready for use and the institutes which has developed the corresponding lab, right? So we have material response, then virtual aerospace, technology CAD, lot of things, right? So mechanics and robotics, then we have vibration acoustics, mechanics of machine lab. Let's have a look of mechanics of machine lab, which is developed by NIT Surat. So this is the home page of mechanics of machine. We have a introduction, then you can go to the objective thing, you can read the objective, then the list of experiments. So there are 24 experiments which are listed over here, and the target audience, if you could see the UG and PG students, the course alignment, if you could see, so this is aligned with lot of universities, so students can take advantage of this thing. And you can see the experiments over here. So we will check out some of the things here. So let's go with some position analysis of Scotch-Yoke mechanism. So you can read the aim, then the theory of Scotch-Yoke, what is the procedure, and then the self-evaluation and simulation. So here the simulation, now here you could see the actual mechanism which is moving, then it is giving the simple harmonic motion which has given. Then we have on the right hand side we have like variables. You can see the crank length, then the theta, then the angular velocity. So you can change and see the variation. You can increase the speed, right? And then we have option like show graph. As soon as you click on the show graph, it will start showing the graph, right? So see how interactive this interface is, right? You can learn lot of things. We know that the Scotch mechanism generates the harmonic motion, So the displacement we can find out by the crank length into cos of omega t. So this is the formula, right? And we can play, like now I have stopped it. So with the angle say at 50 degrees, how much I am getting the displacement. So this is the value. Now you can just change these variables and you can get this displacement value. Now I am changing the theta, you could see the displacement is getting changed, right? So this is how you can play with the software. You can learn the things, and you can check out the things, right? So at theta is at 180 degrees, I am getting some value which is minus, right, because it is on the negative x-axis. For 360 degrees it is on positive x-axis, that's why I'm getting the positive value. So this is how you can interpret the things, you can read the things, you can play with these things, and you can do a lot of things with this platform, right? So this is about the position and analysis of the Scotch yoke mechanism. So let's take some another example. Let's take some a different mechanism and we can check with that. So let's take the position analysis of elliptical triangle. So uh, let's go to the simulation again, and here we have the elliptical triangle. So the things which we are reading in the theory, you can practically, you can actually, you can cross verify those things, right? And this is the online the beauty of online platform, right? Without any physical thing, you are cross verifying things, you can check your doubts, you can play with the things, and you can analyze the things. So here you could see it is tracing the ellipse, that's why it is called as elliptical triangle. And here while stopping you will get the major and minor axis of the ellipse, right? So these are the values like BC and of AC. So at the angle, at the different angle, so you can change the angle and then again you can get the values. So let's see, I'm changing the value, right? So I'm changing the value, but it will not affect the thing because my AB and AC are constant. If you make a change in AB and AC, this is how now the values are getting changed, and at some value I'm getting uh, the straight line, right? So you can check out the same thing over here. At the value of AC, say 105, I'm getting a straight line. So you can check out this thing, like when AB is equal to AC, you will be getting a straight line. So this is how you can analyze the thing, you can get the information, you can get the knowledge, you can see how the different mechanisms work, what are the parameters that affect their motion, and how you can change those things. So all these things you can learn with this platform, right? So let's take one another example of Whitworth mechanism, right? So let's check out its simulation. So here there are the different linkages, and we know it is a straight line motion creator and is used let's say in shapers and planers for the movement of the, let's say, tool. So here it is tracing a straight line, so you can attach the tool over there or anything which you want. So you can change the values, and now you can see the stroke it is getting changed, right? So this is how you can check out, right? You can trace the path, and then we have a velocity analysis over here. You have acceleration, you can change the angles, and you can check out the velocities, the vectors you are getting, right? So you can check what will be the velocity of the slider and all those things. So you are getting all these things also over here. You can navigate through different parameters, you can change the things, right? So this is how uh, this mechanics of machine lab is, and I think there are n number of things you can check out and learn from this platform. You could see there are 24 different experiments which are listed over here. So whatever you are learning in theory, you can practically check on the site without requirement of any physical means, without going to anywhere. So this is the beauty of this platform. So try to utilize it, try to share it to as many as students you can, right? So this is it for the today's session, and thank you for your patient listening. So if you have any doubts, please do write into the comment section. Until then, stay home, stay happy. Thank you.